This is our last section in which we will be establishing identities. And we have a few more different identities that we're going to work with in this section. These identities are product to sum and sum to product formulas. And here's our first set of them. These are the product to sum identities. Now, you may notice that we've got cosine, cosine, we've got sine, sine, and we've got a sine, cosine. And we don't physically have present one that says cosine and then sine. And that's because you can just invert what's in the last identity here and switch it, and it'll become the cosine sine, so it's the same identity. The other set of identities are the ones that take sums, right, like sine plus sine and so forth, into products. So we've got sine plus sine, sine minus sine, cosine plus cosine, and cosine minus cosine. And we're going to jump right in with an example. The identity or the directions here tell us to express the product as a sum containing only sines or cosines. So I'm starting with products, and I want to turn it into something with with sums. And so we're going to use these first set of identities, which is the product to sum identities. So looking back here, this is sine times sine. We're using the second identity, so we're going to have a 1/2, and then we're going to have cosine of my angles subtracted minus the cosine of my angles added. So this is 1/2 times the cosine. And I'll do them in order, but you'll see very quickly that it doesn't much matter here. This is actually theta minus 2 theta. And then we have a subtraction sign. And then we have the cosine of the angles added, so theta plus 2 theta. All right, so we have 1/2. This is the cosine of negative theta minus the cosine of 3 theta. And then what you'll remember is that the cosine of negative theta is the same thing as the cosine of theta. That is an even-odd identity that we have from, at this point it seems like way back when. And then we can distribute the 1/2 through to each term, and we can express this as 1/2 cosine theta minus 1/2 cosine of 3 theta. Sorry, I left the 3 out there. And we have done what we've been asked, which is to express this as a product, express the product as a sum, and this one's a difference, that's okay, containing only sines or cosines, and this one's cosines. All right, so we're going to do the same kind of directions on this one, but it's asking us to go the other direction. We're going to express the difference as a product. So this is the second set of identities. We've got two cosine values that are subtracted from one another. So we're taking a look here, and this will be the last identity on this slide. So this is negative 2 sine. This is the average, alpha plus beta, the two angles added divided by 2, and then sine, and then the two angles subtracted divided by 2. So we have, again, it's negative 2 sine. We have our two angles added, so 5 theta plus 3 theta over 2. And then we've got another sine, and we've got our two angles subtracted. So 5 theta minus 3 theta divided by 2. And if we simplify this pretty quick, we see the end in sight. We've got 5 theta plus 3 theta, which is 8 theta, divided by 2 is 4 theta. And then we've got the sine here, and 5 theta minus 3 theta is 2 theta, and 2 theta divided by 2 would just be theta. And then we're done. All right, and then there's two identities that we're going to take a look at on these types of problems. So looking at this particular one, we see a lot of sort of chaos on the left-hand side. We've got angles that are added, different angles currently, and then we've got some division, and we've got just kind of a regular mess. I'm going to work with the left-hand side, and we're going to use those sum to product identities. So the sum to product identity here is sine plus sine. So over here, this would be the very first identity. So this should be 2 sine of the angles averaged, and the cosine of the angles subtracted over 2. So we've got 2 sine. My angles are added, 4 theta plus 2 theta over 2. And then cosine of the angles subtracted, so 4 theta minus 2 theta over 2. all of this is over 2 cosines that are added together. So that is the third identity on this slip, on this, sheet. I have 2 cosine of the angles added over, and then cosine of the angles subtracted. So I've got another 2, and this is the cosine of the angles added, so 4 theta plus 2 theta over 2. And then the cosine of the angles subtracted, 4 theta minus 2 theta over 2. All right, so on the first one, I end up with 2. Well, let's do this first. The 2's cancel, of course. So I end up with sine, and then 4 theta plus 2 theta is 6 theta. 6 divided by 2 is 3 theta. This is sine of 3 theta. The second one is cosine. I have 4 theta minus 2 theta, which is 2 theta divided by 2 is theta, over, and now I have the cosine, and the angles actually are the same, so this is still 3 theta and cosine of theta, and then, of course, I've got the cosine of theta on top and bottom, so those cancel. So I'm left with sine 3 theta over cosine 3 theta, but sine over cosine of the same angle is, in fact, the tangent of 3 theta, which is exactly where I wanted to end up. All right, let's look at example number 4. Looks and feels very similar to the last particular problem that we were looking at. We've got the sines of angles added and sines of angles subtracted on the left. So we're going back to those sum and difference into product formulas. And I'm just going to go ahead and use one. This is 2 sine of the angles added, so alpha plus beta over 2. I know these aren't going to actually simplify, but that's okay. Don't worry too much about that. And then we have, the cosine of alpha minus beta over 2. And all of that is over 2 cosine. And I have alpha plus beta over 2. And sine of alpha minus beta over 2. Okay, so of course my 2's eliminated themselves immediately. And the angles here match, right? So I've got alpha plus beta over 2, alpha plus beta over 2, the first sets of them. And sine over cosine, just like on the last slide, is actually tangent. So this tangent of this matching angle, which is alpha plus beta over 2. And then I've got the same thing over on the second set, right? There's cosine over sine instead, but it is the same angle, and cosine over sine is cotangent. And so this is the cotangent of alpha minus beta over 2. And of course, that is exactly what the right-hand side is equal to, so we're finished.